Hi, this is Team Eclair, and our project for this capstone year is called Eclair Inventory Management, given to us by our sponsor, Jonathan Klein. A brief team introduction. Jonathan Klein is our product owner and supervisor, and Travis is our team leader. Connor McBreen is our technical advisor. Kelly is our second technical advisor. And then there's me, Martin Lamb, who is one of the software developers and team recorder. And then Jordan, who is our second software developer, who is also a designer. And then we have Connor Small, who is in charge of front-end web development. So to give a brief problem background, here at ASU in the engineering department, there are many chemical labs spread across different buildings, across different campuses. And within these chemical labs, there are hazardous chemicals as well as non-hazardous chemicals. But currently there isn't an inventory system that can keep track of these chemical inventories in real time, and therefore it can lead to an excess amount of hazardous chemicals in these labs. So Jonathan provided us with Eclair, which is a continued capstone project from the previous year, and it is supposed to be a solution to this problem. And ultimately, Eclair requires a front-end web application, a database, and a backend to drive this front end. So to describe Eclair a little bit more, Eclair stands for Engineering Chemical Lab and Inventory Regulator. And as mentioned before, it needs to be able to consistently keep track of the chemical inventories in each lab across many different buildings, and it needs to monitor the maximum allowed quantities, or MAQs, for all the chemicals in each fire control zone, and give out notification when the chemical inventories are approximating this maximum amount quantity in the fire zone. So these notifications would allow researchers and engineering admins to keep an eye out for any incoming chemicals to make sure they don't go into these areas that are approximating this constraint. And also, ultimately, this application will allow these admins and researchers to move chemicals around different labs to better suit according to these constraints, and allow the flow of chemicals to not reach this MAQ in certain labs.
As an introduction to our requirements section, I'd like to present a use case diagram that represents a system overview and 2 user stories, which will show you how our users will be interacting with the system. As a OHS officer, I want to simulate lab configurations in order to meet lab researcher demand. As a lab manager, I want to assign researchers to a lab, which will allocate that lab researcher to a lab space. On the right, you have our use case diagram. Here we have 4 responsibilities and requirements of the system. That is, assign managers, assign researchers, simulate labs with chemicals, and update lab inventory. On the left-hand side of the diagram, you can see we have an OHS officer. They are a top-level privileged user that has access to all 4 actions within the diagram. Our lab manager can only assign researchers and update lab inventories, and a lab researcher can only update their own lab inventory. Like I previously mentioned, we need 3 levels of privilege within the app. How we achieve these 3 levels of privilege within the web and mobile application is to have a user log on. Once a user logs on, their information they provide is then used to create a cookie. In our case, we're using a JSON web token. This web token is then validated. If valid, the cookie will allow them to access certain pages on the app or prevent them from accessing certain resources. For our final set of requirements, we're going to have an interface for lab audits, as well as in-app and out-of-app alerts. Our audit system is going to provide a report style view of a particular lab or a set of labs and their chemical quantities, as well as the maximum allowed chemical quantity for that fire control zone. This is of interest of the OHS officers only, and they will only be able to access this resource. The alert system we're going to provide in-app is for the researchers, and it's going to prevent them from adding too many chemicals to their labs, and it's going to be proactive because we're going to alert them prior to them exceeding a maximum allowed quantity. When that event happens, however, we're going to alert the lab managers as well because it is a hazard that they're trying to add too many chemicals, and we want to alert those lab managers and OHS officers to via text.
Hello, my name is Travis, and I'm going to run you through the current state of the Eclair web application. So we've already kind of built a little bit of the front end, and we actually have a login system currently. So let's go ahead and log in. So as you can see, we've built out a dashboard, and each user will have their different resources that they're available to. Admin users will have all of the resources available to them, such as users, schools, reports, labs, buildings, and there will actually be many more. But for right now, this is kind of a basic implementation of our front end. We've also gone ahead and created different routes in our back end that will allow us to create these different things. So like if I was to create a lab for the building electrical engineering, we'll see that this will actually be created and put into our list. So electrical building lab 2 or 1, we'll create the lab and we'll head back to our list. And you see that the lab was actually created. So as I was kind of saying, this is built and created by our backend. So the current state of our backend has all of our database models up to date with things such as the buildings, the chemicals, the FCZs, which are the fire control zones, hazard class, or the activity logs, and many other things that we will need in order to create a strong backend. We've also created the API routes. So in each API route, we have really 5 methods. We have our create method, we have our read method, which reads a single building or whatever model. We have our get method, which is kind of getting all the lists of schools or list of buildings. And then we have our update method, which is a put, and we have our delete method. So this is kind of all we need for like a CRUD infrastructure, which is really a create, read, update, delete kind of application. And that's kind of what we're looking at with this application that we're building at this time. Along with this, we also have our different authorizations. So we're actually using different roles such as super admin or unauthorized. And it's kind of in somewhat like an AWS, permission levels where we have different resources and we'll give them the methods that they're allowed to use, and we'll kind of say what action is used on these methods. And then another resource that we're using as a team is GitHub. So right here is kind of where we're all collaborating and ensuring that all of our code is up to date, and ensuring, and whenever someone has pushed up new code, we'll create a new pull request, and someone from the team will actually check the code and ensure it's the quality of the code. But we're coming along, and as for next semester, that's really when we're going to start building out more of the front end to really be where it needs to be before the end of next semester. This semester was really heavily based on the back end and all of the database infrastructure and the relations that go into the back end to make the front end robust. So yeah, if you have any questions, please feel free to email us or anything else at this time. Thanks, and I hope you have a good day.
So we've got about 5 stages in the making of this application, which incidentally correspond to the 5 deliverables that we've agreed upon with our sponsor. And those are, first of all, to recompile some of the code base that was given to us from the previous teams in order for us to actually bring this project to an end. And that was to be done by November 1st. And after that, we had the task to provide and create one robust and complete database, which would allow us to incorporate all the features that we've discussed with our sponsor, and that was to be done by November 30th. And once that was out of the way, The next task is to actually create a front-end website to interact with that back end and incorporate some of the basic features that the app needs. And that's to be done by February 10th. And after that, the remaining task will be to add some of the remaining features that need to be incorporated in the app, such as reminders, alerts, and chronological jobs. And that's to be done by March 20th. And once that's done, from that point on to the end of the semester, we will be working on providing support for a mobile platform to work along with the web application that will already exist. And that would include support for platforms such as Android and iOS.
I will now discuss each team member's role in the Eclair project. Travis Daly is the team lead. Connor McBreen is a technical advisor. Kelly Ndombe is also a technical advisor. Martin Lamb is a checker, developer, and recorder. Jordan Plagman is a designer and developer. And Connor Small is a front-end developer. Each of these roles carry with it certain responsibilities. Travis Daly's responsibilities as team lead include creating the base project, setting up a front end, and setting up a connection between the front end and the back end. As a technical advisor, will be working on creating API routes to interact with a database. I am working on a GUI for displaying individual lab information. Kelly and Dombe will be working on designing the database, ensuring consistency between tables and relations, and working on front-end styling and development. Martin Lamb will be creating documentation. He will be checking for team assignments, and he will also create API routes and work on the front to back end connection. Jordan Platchman will be working on updating the current Eclair server to the newest version of the project in order to have a live testing environment. And Connor Small will be creating a system activity log to monitor changes to the database and to work on developing the automated notification system to alert lab managers of excessive MAQs.
Over the course of the semester, we had to learn a combination of technical and personal skills. As far as technical skills, we had to learn how to work with Node.js, SQLize, JavaScript. As for the personal skills, we had to enhance our skills in collaboration, work distribution, and working with non-technical stakeholders. So in conclusion, the problem was that Eclair's current inventory system is inefficient and inaccurate, and our solution is to create a dynamic and user-friendly application that allows them to add inventory, update inventory, and get notifications in real time. So we want to say a special thank you to everyone that's helped us through all of this, our advisor, TA, and professor, and thank you for helping us on our path to finish the project. Thank you.